Hey guys, welcome to this page of the notes, and what we're going to do is look at a couple more problems dealing with mid-segments, and one of those objectives, the learning targets that we talked about, was being able to use the properties of mid-segments to determine unknown lengths or to find an unknown value to solve for a variable. And that's exactly what we're going to do here in these problems. So let's jump into these and see what they're going to look like. What I've done is I've given you a triangle RST. So here it is, R, S, and T. In the diagram, we're going to use it to answer a couple of the following questions. And what I've done is I've given you a couple of mid-segments for that particular triangle. So knowing that, let's go ahead and see what we can do here. The first thing I want you to find is UW. I would like you to find this mid-segment right here, UW. Well, remember our property of mid-segments. The length of a mid-segment, UW, will be equal to 1/2 the length of the side, the third side. Well, since UW connects these two sides, the third side is going to be side ST. So it's got to be 1/2 the length of side ST. Turns out from the diagram, I know how long ST is. It's 10.2. Plug it in. Don't fat finger something on your calculator. 1/2 10.2 UW will be 5.1. Right? So just like that, just that easy, using those properties of bisectors to find an unknown value. Let's keep going and try another one. Now I want you to find an angle. I want you to find angle SVU. SVU. Well, where is that angle SVU? Ah, there it is right there. Angle SVU. I want you to find that angle right in there. Angle SVU. SVU. Find that angle right in there. Okay, well actually, let me go ahead and erase those colors because this is awesome. I really like this problem a lot because what it's doing is this problem is taking us back again to a previous chapter. This is a very common theme here, right? Stuff that we've learned in previous chapters just keeps showing up over and over and over again to help us solve problems. This is no different. Let me show you how this is something from a previous chapter. What I'm going to do is I'm going to go ahead and extend, I'll just use dotted lines to extend ST and UW. So if I extend ST out a little bit further in this direction, and a little bit further in this direction, and I extend UW a little bit further in this direction, and a little bit further in this direction. Here's what I know about those guys. Remember, we know because it's a mid-segment, UW and ST, they're parallel lines. So I'll put that little parallel symbol in there, right? A little arrow there and a little arrow there, because I know that those are parallel lines. So these are parallel lines, which means that this line right here, UV, is what? Well, I'll do it in a different color for you. UV is none other, extend it a little bit further for you here. UV is simply a transversal intersecting parallel lines. That's right. All of those angle relationships for parallel lines cut by a transversal, like alternate interior angles, corresponding angles, same side interior angles, exterior angles, right? All of those angle relationships, boom, here they are showing up again in this chapter on triangles. Absolutely, that's going to happen. So we've got ourselves parallel lines cut by a transversal. What does that mean? Well, the angle we're looking for is right here, SVU. That angle right there, which is an angle that is between the parallel lines, right? It's between the parallel lines, cut by a transversal. So what do we know about angle relationships? Well, what we know is SVU has to be congruent, right? Alternate interior angle. This angle has to be congruent to the angle VUW, this guy right here. Alternate interior angles are congruent. That was one of our theorems back when we did parallel lines cut by a transversal. So, what does that mean? Well, that means SVU is congruent to this guy, which is 41. So, angle SVU has to be congruent to angle VUW. Why? Alternate interior angles. Alternate interior angles. So, what is angle VUW? Well, it's 41 degrees. So that means angle SVU is also 41 degrees. I really like this problem a lot because once again, it's another example of previous information showing up in a later chapter to help you solve another problem. So that's great, alternate interior angles. Don't forget those angle relationships. We're actually going to see another one right now in this problem. So here we go. Let's do another one. I've given you triangle, RST. The diagram below, I got a couple of mid-segments already drawn for you. So here we go. Let's just jump right into this. I want you to find JL. Find JL. Okay, where is J? Oh, there it is right there. So JL is that entire side of the triangle right there. Okay, interesting. So here's what we know. We know that these two guys, this is JL, right there in green, and the mid-segment, right, that's parallel to JL is this one, PN. Now remember the property of mid-segments and the third side. PN, right, is equal to 1/2 JL. That's our property. The mid-segment is half the length of the third side. In this case, rather than have you find the length of the mid-segment, which I already gave you, right there, it's 39, I'm asking you to find the length of the third side. Okay, great. So PN is 39 equal to 1/2 JL. How do I get JL by itself? Yeah, multiply the 2 to the other side, and we get that JL is equal to 39 multiplied by 2, which should be 78. So, using the exact same property, the mid-segment's half the length of the third side, but this time I had you solve for the side of the triangle rather than having you solve for the length of the mid-segment. Absolutely, we'll do that. Okay, let's go ahead and do this one because this is another angle. We'll come back to that one. Let's do PM first. So let me erase those green lines because now we're switching and I want you guys to find the length of PM, which is right there. PM is a mid-segment. I want you to find the length of PM. Well, the third side, right, it's parallel. PM is parallel to LK. This one looks like it's going to work out a little bit more like what we're used to. PM is going to be equal to 1/2 the length of LK, and I have given you LK. I tell you LK is 95. So let's plug and chug. 1/2 of 95. Ooh, that does not look like a 5. That looks like a 5. All right, what do you get? 1/2 of 95, 47.5. Okay, great. I really like this problem a lot for this reason. Here, I have you solve for the length of a mid-segment. Here, I have you solving for the length of a triangle. You need to be able to do both. There's absolutely no reason why you couldn't do either one of those. This is a really good problem. All right, now let's go back because I've given you an angle. So let's go ahead and figure out what you're being asked to do here. I want you to find MLK, angle LMK. I'm sorry, LMK, angle MLK. So MLK. All right, so I'm asking you to find this guy right here. I want to know what is that angle right there, that angle right there. Well, in the previous problem, we saw that it was an angle relationship of parallel lines cut by a transversal. Yep, check it out. I'm going to extend line LK, which is parallel to line PM. Right? We know that those guys are parallel. Let me stick my little parallel symbol in there for you, right? Those are parallel lines. Where's the transversal? Sure enough, right here. This line right there is a transversal. I have a transversal intersecting parallel lines. Now, you're looking for this angle right here. So based on other information given to you in the problem, what else do you know? Well, it turns out I've given you, hopefully you can see it, it should be jumping out at you since this is previous information. This guy right here. I've given you that angle right there is 105. Well, what do you know about those two angles? What's the relationship between them? Sure enough, they're corresponding angles. They're in the same position in different intersections, right? In this intersection right here, angle L is in the top, right? Top right-hand corner. Up here, right, 105 is in the top right-hand corner. So I know that angle MLK is congruent to angle, that would be JMP. JMP. Why? Well, they're corresponding. Let's see, yeah. I hope I spelled this right. I think corresponding is too. Apologize if I misspelled corresponding. They're corresponding angles, which means that they have to be congruent. So angle MLK is equal to 105 degrees. Once again, we see this idea of parallel lines cut by a transversal showing up here in this chapter on triangles to help us find an unknown value. Okay guys, what we'll do on the next page of the notes is take a look at a couple more ideas, problems dealing with midsegments, so I'll meet you there.